achieved as the chief minister, is that they will do out of the casualty conversation to have with the I want to see what we need it's still political management by a women with the right of some people with the right of I got a last email and normally the Mr. Friday NITI lecture guy was so energetic. And so I'm still kind of advanced this to a guy that seems to, and since I haven't heard of it, I will go into my work and find out better than remarks rather than closing remarks. And then leave it as a report. This is the more sessions. So I was these were but I requested that the statement as to say is that this dog is very positive. I find that it's definitely now, and of course, the right to buy, I don't think that in the house has become like vendors. There is a language, and then serial numbers or sort of relationship with each other, etc. And that's the rest of you. So I would just say, present day some countries. So now we were advised by the draft and legally whatsoever, most of the Soviets were there, is that the line of political violence is like a chair. I think that would belong as it were success from the fact of the today, as a big on for a really long time. I wrote something of to do coming out to and I went to listen to my alma mater and it was shared with me, to start with me, and speaking speak about so we are guys like the genuine purpose revolution as silicon lens. And we have seen all the kind of ways, small in the development of the silicon revolution, there's been this big activity about because of the rise in our particular customers. That AI will high transformation, and that is important for us to take on the ground. So that is, as it were, why the PM attended the AI summit with President Macron in Paris. And as you know, the Trump administration and the UK Labour administration did not sign up to the declaration from there. So I suppose many of us would say that we are finding that the digital revolution actually had a dark side in terms of mental health, in terms of fake news, in terms of social media, what have you. There has been a lot of discussion about the dark side of AI, but here we are to learn about the bright side of AI. Nothing is without risk, but the question really is if, as it were, the animating vision of all government since independence, and now particularly with Viksit Bharat, is that
it is the purpose of the Indian state to transform India economically and socially, which is also in our constitution, then the challenge for NITI, led by the Frontier Technology Hub, is to understand and grapple with how that transformation can be accelerated by the new technologies. I'd make a final point and then we'll defer to the organizer of the program, which is that technology advances in the advanced countries incrementally, a little bit like rings being added to a tree. Okay, so mobile telephony was a nice add-on, but people already had universal plain old telephone service. For India, it was transformational. And so I think the notion that things that are seen to be transformational, even in the West, are probably, as it were, transformational to a power of 10 in a society like India. And this comes at a time when we are equipped to grasp the opportunities. So thank you for your patience. I think the hall is full. I think it's now 10:30. I will listen very carefully to what the speaker has to say. Let me welcome him and thank him for being here. Let me welcome honorable members who are here as well. And I don't know who I hand over to, but pleased to be here.
Thank you, sir. I would now request Ms. Devjani Ghosh, Distinguished Fellow and Chief Architect of NITI Frontier Tech Hub, for delivering the opening remarks.
Thank you. Thank you, respected Vice Chairperson, honorable members, all other dignitaries and guests. You know, it is such a fantastic way to start Monday, start the week with such an important, such a pure, unfiltered inspiration, by which we are going to hear in the next 30 minutes. I'm going to keep this very, very short. The world today is divided into two. On one side, you have the people who get disrupted, the disruptees. And on the other side, you have people and nations who disrupt. Most of us are in the first side, which is disruptees. We wake up every morning absolutely amazed with the next big disruption that has happened. And then we try and figure out what do we need to do to adapt to these tech disruptions. There are very few people today who belong to the camp of disruptors. There are very few people with the vision, with the know-how, and with the courage to actually work on creating these disruptive technologies, innovations that pretty much not just change the world, but shape our future. And as NITI Frontier Tech Hub, it is our goal to bring such brilliant minds to India and to talk to all of you so that we can hear from them firsthand and we can understand from them how this process of disruption works, because I do believe this is going to be the biggest skill to have in the era of AI. So today, it is my absolute pleasure to welcome one such visionary disruptor, Dr. Pushmeet Kohli of DeepMind Google, to NITI Aayog. Dr. Kohli is one of the foremost scientists in AI, recognized by Time magazine as one of the 100 most influential people in AI. As the head of research in Google DeepMind, he has led groundbreaking projects, including development of AlphaFold. If you are in NITI and if you've met me, you have heard about AlphaFold and how game-changing it is, and several other game-changing innovations, which I'm sure he will talk about. Beyond his contribution to AI, I also know know that Dr. Kohli is a very passionate believer in India, in what we can do, in how we can lead this revolution in AI. So without further ado, I would like to invite Dr. Kohli to share his insights on how India can move beyond being a participant or a disruptee in the AI innovation revolution to becoming a disruptor, but a disruptor for a better tomorrow. Thank you and welcome, Dr. Kohli.
Yeah, thank you. Thanks a lot. Um, Thanks a lot for this introduction. It's such an honor and a pleasure to be here. I hope to sort of give you a hint of what is to come by showing you the state of affairs of AI. Just a bit about my background before I start. I am a computer scientist by background. Started my career in Microsoft, working on machine learning and computer vision and graphics. And over the last 10 years, have been at Google DeepMind, where I founded the science program and lead the science and strategic initiatives. So the title of the talk is the AI revolution, the opportunities and challenges for India. But let's start with the question of what is intelligence? How do you quantify it? When you're thinking about artificial intelligence, we understand the artificial bit, but what is intelligence? Now, when we think about intelligence, there are three sort of broad categories of intelligence that you can think about. The first is normal human intelligence. So something that can be achieved by any human, most humans. Most humans can recognize images. The images, whether an image contains a car or a dog versus a parrot. Most humans can do that. Machines found it really hard. When I started my career sort of 2 decades back, I was working on computer vision. This was an incredibly hard problem. I used to tell my mom, we built this system which could detect a cow, and she was not impressed. She was like, what? Like, anyone can detect a cow. What are you talking about? Like detecting a cow in an image? That's what you're doing. You're wasting your time. But that's what it is. Like human intelligence is very powerful. It has evolved through evolution, and machines find it hard to do these things. But that's basic human intelligence. Now there's next level of intelligence, expert intelligence, which is people who have studied for many, many years and have become experts in domains of mathematics, in domains of healthcare, in domains of law, and they can sort of do things that we mere mortals can't. And so achieving a machine that can, or achieving a system that can exhibit that level intelligence is another sort of breakthrough. Can you go beyond that, meet that expert level intelligence? And then the final thing is beyond human level intelligence, beyond expert. There is nobody on the planet which can solve this problem. And yet this machine can solve that problem, that cognitive problem. So I just wanted to mention that there are these three cognitive tasks and three sort of ways of how intelligence manifests itself. And when we talk about the AI revolution, it is touching all of these three, right? And it's important to make sure that we consider those three things in a sort of focused manner. So I belong to this organization called Google DeepMind, which was founded with a very humble and modest mission of building AI responsibly to benefit humanity. I can give a whole 1 hour lecture on how do you define humanity here, but let's keep that for another day. Then how do we sort of accomplish this mission? If you know about Google DeepMind, the basic history of Google DeepMind or the lineage can be traced back through these three phases. The phase one of DeepMind was validating the thesis that you can build systems that can self-learn and go beyond human level intelligence. And that was demonstrated by our work on AlphaGo. If you have not seen that documentary, I would really encourage you to see this. It is very sort of entertaining as well as a bit emotional, surprisingly, where a system was able to self-learn and beat the Go world champion. But that marked the end of phase one for DeepMind. And in fact, I joined DeepMind at the end of that phase because I was more interested in actually, now that we have validated this thesis, how do you use it to have impact in the real world? And that's what we showed with AlphaFold, which solved an amazingly hard and impactful problem that I'll talk to you about. And then finally, the third sort of phase that we are now in is basically building these models which are not only specialized, which can solve the game of Go or solve protein folding and so on, but they can be general purpose models. They can do multiple tasks. And that's the phase that we are in today. So if you're sort of not living under a rock, you would have seen the term generative AI. As that was explained, that it is all over the place, LLMs and chatbots and so on. Essentially, what you have is a system that can exhibit general purpose intelligence properties. It can solve general purpose tasks. You ask it to do something and it will sort of generate an image, it will generate a video, it will sort of write software for you, something that we sort of thought would take a specialist who has trained over many, many years to be able to do. Now these models can do it. They have amazing mathematical reasoning. They can use things like internet access. RAG here stands for Retrieval Augmented Generation, which is that they can retrieve information from the web which they need to solve a task. So they can automatically think about what is needed for them to learn to solve a particular task. But AI is more than chatbots, and that's what I'm going to tell you today. That this is not just having a chatbot like that you can talk to and get your sort of tasks solved. It is much more than that, and it's really shedding a light on what is the fabric of reality, what nature is all about. So I lead this team which is called the Science and Strategic Initiatives Unit at Google DeepMind. It's one of the sort of it's one of the 2 or 3 research units at Google DeepMind. And our aim is to go for transformative impact in science and AI using the techniques that we have. So the way to sort of think about our operating philosophy, the way I sort of tell my team how we go about things is, so the algorithm that we use is take a problem that everyone in the community, there is complete consensus that it will be transformative. And it's going to happen. It will be transformative, this problem will be solved. When this problem will be solved, it will be transformative. Everyone has this consensus. Okay, that's step one. Step two is that although everyone believes that this is going to be transformative and it will be solved one day, everyone believes that it will not be solved in the next 10 years. Okay, so it's extremely hard. People are convinced that this cannot be solved in the next 10 years. And then the third condition is we believe that the whole consensus is wrong and we can do it because of some key insight in half or 1/3 of the time. If those 3 conditions are met, my team takes it on as a mission that we go after in a very focused manner. And we go after it in a fundamentally multidisciplinary way. We don't sort of say we are machine learning scientists, we are going to solve this problem. We say we are biologists, we are physicists, we are chemists, we are mathematicians, and we are going to sort of do this in a fundamentally multidisciplinary way. And I'll sort of give you examples of how this sort of works out. Now, another way of thinking about what is a transformative problem is to think about root node problems. So certain problems are root node problems because once you solve them, you can unlock a lot of progress. For instance, if you can solve the problem of quantum chemistry, then all these problems that we are facing today, like climate change and so on, they can be tackled because we can build high temperature superconductors, we can sort of develop better batteries, we can do material design and so on. Similarly, if you really understand protein folding, which is the building block of life, you can basically do better develop better drugs in a much more efficient fashion and so on. So these root node problems are what we first prioritize in our work. Here is this root node problem. This is what a protein looks like. This is a language. Like in India, we are very familiar with multiple languages. We are a country of many languages, and we understand the importance of being able to translate and being able to converse in many languages. This language is the language of nature. This encodes the building blocks of life, proteins. If an alien species was to come into this room and analyze what's happening chemically, it would describe the scene as a bag of water giving lecture to the number of bags of water. Because chemically, most of us, our body is water, right? 60 to 70% of you and me is just water. So what is this amazing magical thing that is allowing this mostly water to be able to make these intelligible sort of sound waves, and you to be able to interpret those sound waves and reason about them? All of this is essentially the magic of proteins. Proteins are the building blocks of life. These are the molecules that are interacting between you and me that are sort of influencing every single function that we know of in life. And we don't know how they do it. There are 20,000 proteins in the human proteome. All of you and me, like every one of us, just 20,000 proteins. That's it. But we don't know what the structure of those proteins are. We know everything, like all the shapes and the functions of a car, but the most important information, the most complex system that has been built by nature, we don't know how it works. That's the problem that we took on with this problem called AlphaFold. So what this system does, it takes that sequence. It just takes that paragraph of amino acid sequences, like 20 amino acid sequences, 20 amino acids represented in the sequence, and tell us what is the 3D shape of that sequence. What is the 3D shape of that protein? Any guesses on what this protein is? Without this protein, none of us will be here today. It's hemoglobin. And you can see the hint is that pocket that is shown in the middle of that 3D structure is where the oxygen binds. And if there's a mutation and it's not able to bind to that oxygen, it's gone, right? So it's so important. AlphaFold solved that problem, and in 2020 we released it. We announced this breakthrough. You can see how accurate it was. So the ground truth is in green, the ground truth structures are in green, and in blue are the predictions. You can see the wide variety of predictions that are required. On the very left is the OR fate protein in SARS-CoV-2. Now, the pandemic was a real eye-opener because it really brought home to everyone on the planet how little we know about biology. We think we are a big deal, right? And that small virus shut down the whole economy, the whole global economy, right? And many of you at that time might have seen the spike protein, the structure of the spike protein. And the reason why people were able to find the structure of the spike protein was because it was very similar to SARS-CoV-1. But the virus is not just composed of the spike, it is composed of many different proteins. And scientists did not know the structure of those proteins. We could use AlphaFold to find the structure of all those proteins and create the accessory protein, SARS-CoV-2, which we were able to make predictions about in a matter of seconds. This process typically used to take sometimes years, whole PhD worth of work. And many people have been given Nobel Prizes for discovering the structure of a protein. And now you have a system which can do this in a matter of a second. That is rate of progress. That is what is being enabled by AI. That is the transformation disruption that's happening. Now, where is AlphaFold used today? It's used across the board. You can not only use it for developing new drugs, you can use it to develop enzymes for decomposing plastics. You can think about antibiotic resistance. You can treat neglected tropical diseases. That person working in South Africa, Latin America, or Delhi, who was interested in figuring out the structure of a particular protein which is involved in malaria or Chagas or some other tropical disease, they had no chance to get the structure. They did not have access to a beamline or a synchrotron to be able to find the structure of the protein so that they can drug it. Right? People in Oxford could do that, but even with a lot of money and time. But now what AlphaFold did is democratize, accelerated, and expanded science. That person who is working on these diseases can now click on a click of a button, find the structure of the protein. There are two, and this slide is out of date. We actually found the structure of all proteins, almost all the proteins that are in nature, 250 million of them, and made them available at a database so that anyone can just see those structures. 2.7 million people have now used that database in 190 countries. Now, let's just stop and think about it. A few decades back, I counted the number of people who were interested in protein structure prediction, who were studying structures of proteins. They were getting Nobel Prizes and so on. They were on my fingertips. I could actually say these are the people who are working on that. Now there are 2.7 million people studying structures of protein. If that does not tell you the rate of progress that has happened in the human civilization, then I don't know what will. It's a great testament of the progress that is being made by humanity in our understanding of nature. But we are not done yet. In fact, after AlphaFold 2 was announced, I got a lot of celebratory emails. In fact, one email from the Nobel Committee, and this was one of the fastest Nobel ever awarded. The AlphaFold paper was listed into 2021, and last year we were awarded the Nobel for the system. Now, it's an amazing achievement. At the same time, along with these celebratory emails, I got an email from, many emails actually, from parents of small children. And whether they are somebody who have low resources or somebody who are a billionaire, they were actually in the same camp. They wanted a treatment for a rare genetic disease, and they were hoping that AlphaFold could solve it. But I had to be the bearer of bad news and say that while we have made this amazing breakthrough, we are not done. We can't help you today. And so there is a lot more that needs to be done, because our biology is much, much more complex. Nature is much more complex, and we are just at the start of just scratching the surface, all of this, even though we have made so many advances. So we are now going beyond understanding those proteins which are the building blocks of life. We are really trying to understand the whole language of life, our genome. How do cells operate? Why does one cell become a cancerous cell and while the other doesn't, right? What happens at the phenotypic level? Like if there are changes that happen today, how do they make us susceptible to certain diseases? So we are trying to understand all these translation problems using AI. And in fact, like if you think about our genome, in fact, I was telling you that proteins are like the Lego building blocks of life. Everything, like all of you and me, are made of proteins. DNA, if proteins are the recipe, DNA is basically the recipe book. So the recipe book contains the ingredient section and then how those ingredients are to be mixed. And so those are called the coding region. The ingredient section is called the coding region, which basically says which proteins should be developed in the human body. in any sort of life form. And then there's non-coding region which says how should these proteins be expressed. We are making progress on all these sort of fronts. But that was just biology. I have similar programs and similar projects and similar breakthroughs happening in physics and chemistry, in maths and computer science, in sort of general scientific sort of processes, and then very sort of appropriately, as Suman sort of mentioned, there are a lot of risks, and we are using AI to actually handle those risks themselves. Let me sort of give you a quick snapshot of all of these things. So in physics and chemistry, there are essentially 20 to 30,000 stable inorganic crystals, which humans know. 20 to 30,000, right? And now when we talk about eras of humanity, we sort of talk about human development in the form of the Stone Age, the Iron Age, the Bronze Age, and now, as someone mentioned, the Silicon Age. So you can imagine how important these materials are that we actually name ages and eras based on the material that was being used. So imagine if AI can come up with amazingly new materials, superconductor that can transform our ability to manipulate energy. If you think about it, a lot of progress that has happened in humanity is basically the ability to generate and manipulate energy. That's what it is. And if we have better materials which are able to sort of do that more promptly, amazing breakthroughs will happen. I told you there were 20 to 30,000 stable inorganic crystals in humanity. System, the norm system, this stands for graph neural networks for material exploration. It said, no, not 30,000. There are 2.2 million crystals that I think I'm predicting are stable at room at 0 Kelvin. That's orders of magnitude more. There are many candidates better for battery sort of construction, for superconductivity, and so on, that are lying in that database now that scientists are sort of trying to synthesize and measure the properties of. That is the transformation I'm talking about. That's a 100x transformation I'm talking about. The next system is GraphCast. So since the start of time, we have been trying to predict the nature. We are trying to predict weather, right? What will be the weather tomorrow? What is the weather like, especially coming from a place like London? All you talk about is basically the weather and the lack of sun. But weather is an important element. And a lot of scientific breakthroughs have been focused on weather, and we use supercomputers. Most of the sort of supercomputing resources on the planet are essentially used for simulating weather sort of control. It used to take a supercomputer sort of a whole day to make a prediction. We can do this same thing in a much more accurate way by running our new machine learning model on one chip, one single chip in a minute. This democratizes weather prediction. Now, the 3 or 4 labs in the world which had access to supercomputing resources are not the only ones that can predict weather. Every single one can, like a lot of people can now predict weather for their local region and so on. And this system is not only democratizes sort of weather prediction, but actually making it much more accurate. We can track cyclones many more days in advance than classical sort of systems. Fusion, I talked about energy, right? We have seen, like if you look at one of the challenges that is facing humanity, it's climate change. And we need access to a non-carbon sustainable resource, right? And there's a lot of development that's happening in India on sustainable energy production. But fusion is one sort of key sort of holy grail that has been sort of that has been hailed by scientists as something that is going to happen eventually. We know it happens. The sun is based on fusion, right? It is a source of abundant, sort of limitless energy. The issue with it is that it's very hard to sort of control. It's sort of stabilizing sort of a plasma where fusion can happen is extremely hard. And we have these reactors like tokamaks, which are trying to stabilize that plasma using magnetic fields. And they work with very high precision control systems that have been designed by humans for many decades. The issue is that if a physicist wants to understand the shape of a different plasma configuration, which is much more energy efficient or much more sustainable, you can't do it. They have to wait for another 10 years for the controllers to be able to sort of fine tune this. With AI, we can do it in a matter of minutes. We can learn all this stuff in simulation, and then actually we have shown that you can sort of take the policy, implement it on a fusion reactor, on a real reactor in EPFL in Lausanne, and control sort of plasma stabilization. That was just physics and chemistry. Maths. We are seeing tremendous sort of improvements in mathematics, our ability to solve complex mathematical problems. There is the International Maths Olympiad that happens sort of every year. It's like the Olympics of maths. Like the Indian team actually did quite well last year. And like these people are actually, like there are field medalists who have told me that these problems are such at a high level, solve it, but it might take me a week or a month. These are such hard problems, and now we have these sort of systems which can operate at the level of an International Maths Olympiad silver medalist. This is already beyond what you and me, I cannot solve many of these problems. So this is really already at the beyond sort of expert level intelligence in some sense, in mathematical ability. We saw, in fact, last week, how we are now taking sort of systems which are learning from literature, the scientific literature, to come up with new intuitions. How do you deal with problems in science, like antimicrobial resistance and so on? So this AI co-scientist work that was released, it could really exploit the process of predicting and proposing new hypotheses, scientific hypotheses. Finally, I come to the risks. So I have made the positive case. Now I'm telling you the negative case. The negative case is basically we think of human intelligence, we understand it, like we know how people react and how people behave. Somebody has to take a driving test. Then we think, okay, they have shown the ability to drive, they are on the road. This is not the same thing for AI systems. AI systems are much more complex. The generalizations that you and me make about individuals around us, our friends and so on, those generalizations do not exist for these kind of systems. They can be superhuman in certain abilities and then completely different in other abilities. And also, like they are producing a lot of generative AI, and that generative AI content can be used for malicious purposes as well. So, in fact, we have built a system called SynthID, which makes sure that every single generative AI content, at least from Google, when we are developing these things, whether it's an image or a video, we embed it with a very imperceptible fingerprint. It's like in the signal itself. And it allows us to detect which image was created synthetically and which was by our model. And so we can expose that to users so that they can understand for their own purposes whether this was synthetically generated. And if somebody is using it for a malicious purpose, then we can detect that. Okay, so now coming to finally the implications for India. Now, if you think about it, what I'm claiming is that there is an era of abundant intelligence that is coming. So what should be India's response? Now, first, you can see it as a competitive threat, right? Because India, in some sense, is the biggest producer of intelligence. If you think about our service industry, like the amount of exports that we do in terms of we produce a lot of intelligence. Also, a lot of the CEOs of companies are originally from India, and so on. So there is an element that it's going to disrupt our economy in some way. It will transform the economy in some way. But also, India is the biggest consumer. It has the ability to be a biggest consumer of intelligence. Think about all the different elements that are needed. Today, you and me can get access to high quality healthcare, high quality sort of education from an IIT, from sort of a doctor who has been trained in reputable institutes like AIMS and so on, that person living in a sort of gaon in Bihar, in Jharkhand, in Uttarakhand, in Kerala, does not have the same privilege. But now, if I'm telling you that there are systems possible which can democratize intelligence, like the ability to educate, the ability to diagnose, is transformative. So India has a need to consume intelligence, consume all these amazing abilities. So there's a very important implication for India to leverage this technology to really transform its society in that way, to make sure that these services are accessible to the wider population. So in terms of what are my personal recommendations, I would think first thing is education, right? Really invest in interdisciplinary talent, because it's not about learning machine learning or AI. It's about basically using it in a context, using it for a purpose, because the purpose matters. The proof of the pudding is in the eating, not in just the construction of the pudding and then seeing that, oh, it's nice pudding, right? You have to eat it, right? You have to actually see how it sort of impacts your economy and the citizens in the country. The second thing that we have is basically an amazing source of data, amazing insights. AI does not happen in a vacuum. It does not happen in a vacuum. You don't get intelligent by just being in a room and just thinking about it all day long. You get intelligent because you get experience. You get intelligent from rich experience. And that's what AI systems have as well. The ingredients for AI systems are data, compute, and compute, we already know how important it is compute and and implications for energy usage as well. And then finally, it's talent. And I think those are the three things that we need to invest in. And in fact, India has a lot, right? It has data, so we have to build talent, and then we have to also think about compute and energy. And then finally, really build this sort of ecosystem that can flourish for the whole country. So finally, I'll just wrap up by saying that we are at the start of an amazing transformation that's going to happen. And the time is sort of now to really think about how do we leverage. There's a strong wind blowing. Now the question is, can we put up the sails in the right way? Because it has the ability to transform the society and the world, in fact, not just India. With that, thank you.
Thank you, Dr. Kohli. I would request you to take a seat here. Dr. Kohli, thank you for your invaluable insights. I'm certain the audience would like to engage further. We now open the floor for a 10-minute Q&A session. I request our audience to keep their questions brief.
Hello. Right. Good morning, Mr. Kohli. This side. I wanted to ask you how exactly would AI be useful in improving the accessibility of healthcare, especially in far-flung areas like you mentioned, the villages of Bihar, Jharkhand, Kerala. How exactly would we work on the accessibility part? Like AlphaFold and everything, I believe, is on the diagnostic front. But in terms of policy making and accessibility, if you would elaborate. Thank you.
Yeah, so in some sense, we are seeing already that, especially in the context of these models being used by the rural population, they have been sort of using technology to figure out which crops they should plant and so on. And the models today, they can actually do a lot in terms of healthcare and sort of corporate healthcare and so on. We need to make sure that those models are reliable. So if you look at many of the models that are out there in the market, right, whether it's Google Gemini or OpenAI ChatGPT or sort of Anthropic Claude and so on, they are providing, in many cases, such information. What we want to make sure that that information is actually correct, right? So there's that element, and the people will know how to use use and to be able to communicate with these models. And finally, there's a big element that many of these models today are developed for the English language. So there is a key element of making sure that these models can communicate with users in their own native languages, so that they can sort of understand what is the information needed for that person. In fact, I was in Bangalore last week, and the Google DeepMind team in Bangalore have been working with the Institute of Science on this project on really sort of expanding the abilities of these models for Indic languages, so that you can have people can communicate with the model in their own native language. Say that, see, I have this problem, like what can I do with it, right? So, I mean, there's an element of the regulators have to actually deal with that issue as well today. Like, in fact, we see, in fact, one of the most common sort of complaints that I see from doctors is basically now everyone is a doctor because they use Google. So there is the element of that the technology has to be used in a responsible manner, right? But there is, I don't see any specific hurdle in a number of years. Once we have made these models much more robust and we have tested them properly, that they can be part of the healthcare ecosystem, right? And really used by clinicians themselves to expand their ability to serve a larger patient base.
Thank you.
So thank you for the insightful session. So my question is regarding the closed access and open access. So AlphaFold 3 is originally closed, but then you opened it. So what is the result behind keeping it closed access, but the way going forward, we might have to open access. What are some of the challenges that you see in open access?
Yeah, so this is a very important question. I hinted about this in the context of AlphaFold when we were thinking about the predictions for SARS-CoV-2. They're very powerful models, and you have to really think about how models want them to be used for the greater good and not for malicious purposes. So, especially in the context of biological models and even for the general purpose models, we want to make sure that the good users are enabled, but the bad users are enabled. We want to prevent them. So, in the case of AlphaFold 2, there are a lot of due diligence from scientists, from people who are working on safety to understand what are the positive use cases and what are the negative use cases. What are the harms that someone can do with these models? In the case of AlphaFold 2, it was clear that the benefits far outweigh the risks, and therefore we open sourced it. In the case of AlphaFold 3, that exercise needed to happen again. So we shared the model and the server, so people can use it from a web service, from a server, and most of the scientists actually use that from that perspective. Now, some people would want to use the model and build on top of it, right? For improving the model in certain ways, or for some other purposes, to make sure that that use case is properly vetted. We needed to go through that whole process of reviewing it, seeing what are the risks, what are the benefits, whether the benefits outweigh the risks. Right? So the accessibility question with a powerful technology has to be considered very carefully. Right? We want to make it more accessible, but at the same time, not to malicious actors.
So, thank you so much, sir, for the insightful session. Firstly, I'm working in agriculture division. So my question is specific to sustainable agriculture systems. As you are aware that agriculture systems need to be evolved continuously so as to adapt to the changing needs of climate change, soil deterioration. Now, we have one certain model of sustainable agriculture system as on today's date. Say, for example, we call it organic farming or natural farming. this cannot be replicated as it is across the geographies. So the first question is, how can AI help me develop location-specific models of sustainable farming systems that could be suited to different parts of India? And number two, how could these models be, with the help of AI, fitted across a time duration of next 30 years, 40 years? How could AI help in keeping them evolve? What sort of action do I need to incorporate in policy making so that AI could keep it timeless?
Yeah. So I think the main thing to think about here is AI essentially is giving a power of cognitive ability to basically think about a problem deeply, right? Using a very wide variety, vast sort of amount of knowledge that a system has access to, which sort of a normal human cannot read the whole of the content of the internet, or with all the scientific papers that have been published in PubMed, all the agricultural papers that have been published ever by scientists, right? This model can read those things. So it can, in some sense, generalize and answer questions and reason about and try to do problem solving from the perspective of giving us a very specific solution or proposing a very specific solution to the problem at hand, right? In a specific location. In a specific location, there might be certain soil conditions, certain sort of accessibility, water accessibility sort of questions that the model can take into account and then propose a very specialized, personalized solution. How will this happen? This will happen when people who are actually on the ground understand how to use the system. Right? So this is why education is extremely important. We can't sort of dictate, say, you should be using AI models. That won't work. If people understand what are the capabilities of these systems and how these systems can help them, then we don't need to make any declaration. They will use these tools themselves. Nobody has told people to use Google. Right? They use it by themselves. So there is a natural element of people sort of figuring out what is this useful for, and they want to solve problems that they are facing, and they will find any way to sort of solve it. So the main point for policy making is education, making sure that people understand what are the capabilities, the strengths, but also the weaknesses. The weaknesses also sort of important. It will be sort of a servant to just sort of talk about the positives and not talk about the limitation, because the person who uses the system says it doesn't work for me. Let's just I'd never use it. Right? So it's really important to make sure that people understand where these models will fail as well.
When you hear such presentations, actually throws up more questions than provides answers, but that's the good part of it. I work in the field of smart government, government solutions for the government. And I have a few questions, but I'll try and limit it to 2 or 3. One is that in India, we have this continuous debate about whether we should focus on foundational models or build on applications and not work on the foundational models. So this is kind of a debate within the IT community on this. So what's your view on that? On the penultimate slide that you gave about how should India go about it, and you talked of data, you talked of talent and interdisciplinary talent. So can you kind of dwell a little more on that? What is the way forward? And those are broad pointers, but how do we take that forward? And would it be a good idea to, throw up open challenges and maybe with funding, philanthropy, there's a lot of money available actually, but how do you direct that into something to solve problems of particularly healthcare? Would that be a good idea? Thank you.
Yeah, so I think these are all very important questions. Starting from the first, the whole debate about foundation models, right? And I've seen the press as well I've seen like basically arguing for sort of foundation model. Let's focus on the applications and so on, while there are other people on the other side saying we have to work on foundation models as well. See, the important, you learn about something by playing with it. Right? Knowledge is very practical. Theoretical knowledge is not very useful. So part of it, I think India has to have some ability to be able to understand what it takes to build something of a foundation sort of model. And I think that experience, that expertise as a country, I think that would be sort of important, not only for building up expertise in such things, but for two other reasons. One, for understanding the strengths and weaknesses of these systems in a very deep way. And the second is to specialize these sort of foundation models for the Indian context. So, like I mentioned, especially in the Indian context, the notion of Indic languages, that we will need to have models which understand Indic languages in deep way, right? Not in the sort of, and if you train these foundation models on the internet contains a very small proportion of Indic languages. So if you want a system that is able to understand the culture, the values, the broader sort of context in India, then you have to train it somehow to be able to have that knowledge and have access to that data. So that's so sort of I'm not saying sort of spend a huge amount of money and sort of restart from scratch. I'm not saying that. I'm saying leverage what is out there, but also at the same time sort of make sure that we can specialize it for the Indian context. And also especially there are other issues as well, like security issues, like these, when we think about technology, we think about the technology stack has to be properly vetted. We understand the technology stack. In that $2 billion parameter model, do you understand? No one understands what's happening. In that it goes to billion parameter or 10 billion parameter, sort of 80 billion parameter models. So, from a security perspective, or from a safety perspective, one way to think about it is curate the data, curate basically the whole learning process. Anytime you are basically having an external dependency on some things, that's fine, but there are trade-offs to be made there. Now, on the second question of building up expertise and what should be done, I think AI is as much a scientific discipline as it's an engineering discipline. It's really important to invest in the engineering infrastructure, the computing infrastructure, and also it's not just let's buy a lot of chips. Those chips have to be connected with each other. So the interconnectivity there, where you can train the models, what's happening, that's also very important. So the greatest sort of example, in fact, for India is, from my personal sort of recommendation, which is what I recommended to people ask me from the government of India, is think about ISRO, what ISRO have been able to do in the context of space exploration. So it's a big engineering challenge, right? And I think building up that capacity to really understand the discipline in a very engineering focused way and to build that infrastructure and talent pool and expertise is really sort of important.
Morning, only I'm from the industry. Just a question from what was last answer. What you've seen in the last 1 year is that, from 1 to 1 parameters are coming to a mixture of parameters. And now I'm also talking about few parameter models, which can be working on the CPUs instead of the GPUs. And that looking at the GPUs having what Vortex levels here, OS and from everything. What should be the journey ahead as far as foundation models, specifically for the Linux concerns? So when resident large management will call that as well as discussion that we found some also was concerned. So invest in grabbing right now, we should be value. We're starting on some challenges to the value. This is where their insights on challenge labels, probably what's what of financial use. Secondly, I like to also build upon the future of agentic world, which everybody's talking about. And this is really important as far as our skill support systems are concerned. Where we want the artificial intelligence to give us the kind of decisions using labels which can be trained by these parameters of our complete skill support metrics. Investing as far as environment is concerned, as far as integration of large data which is residing in our legacy systems. So you have the roles and you have any different platform, which is live for last 20 to 30 years. But hereafter and try to get which is right now the legacy devices. So there are a few thoughts on this.
Yeah, so I think let me make a broader sort of point and then talk about the specifics. I think the broader point is that when we are building, when we have a technology like AI, right, and it's basically not, it's not like a program, right? Well, this is the correct program. Like I'm writing a program to add two numbers, or I'm writing a program to sort of multiply sort of 1 to 100, and I can know what the program does. I can verify each step. That is not the case in the context of these models, right? These models are not perfect, and so I'm not a sort of I would caution on the use of models for sort of military purposes, particularly on the context, because of this sort of context for some ethical reasons, but also lack of control. Because, like in the military, one of the things that my friends sort of who went to it and so on, it's very important to think about sort of control and to be able to make predictive decisions. And if you have a model which is unreliable, then that's basically alarm bells should be ringing. Unless you basically understand its behavior completely accurately, it should never be brought close to any sort of weapon system, right? So I'm sort of, I think there's a whole debate that is happening across the world as to the use of AI in the context of military applications and weapons, and I think this is a sort of big ethical sort of debate that needs to happen in the world because the technology is not very simple. It's quite complex, and we don't understand it completely. So there will need to be a lot more work to understand the weaknesses of these systems and how they can be manipulated and exploitable before sort of I would caution against those. But at the same time, like with any technology, sort of the military has to sort of work on it. So I understand the need, but also from the position of a scientist. Knowing sort of what are the limitations of this technology, I would be very cautious.
Dr. Kohli, thank you so much for a very insightful lecture. I'd like to get back to the basics, what you mentioned in a couple of words. You said democratization and of AI. I still feel that there's a great neutrality. I'm not sure that the very neutral. Do you think the fact that AI will ever be democratized, you think there's a need for a regulatory mechanism? We're already speaking in terms of who has more processing power. You mentioned yourself, it's not just science, it's also engineering. It's a question of who develops a higher processing power, but not have a shared electricity. And I think we have Mr. Sam here for a while. This is a really good check
the unparalleled growth we have is to in terms of energy and processing. So where do you think of the heading? I mean, it's going to be, I mean, still have ones who have a first mover advantage, the large corporates. Do you think they will ever be subject to any form of regulation? I don't know whether that question was, I know it's as like, that was the piece.
Yeah, so I think with any powerful technology, it needs to be sort of, it needs to have oversight, right? And it needs to have oversight from the civil society, from policymakers. So I think that is for sure. So if you have a sort of technology, you need to be able to understand it, you need to be able to sort of be able to guide it. That sort of guiding process has to be done in an informed manner, right? So regulatory.
Dr. Gordon, thank you so much for absolutely a wonderful section. My last question to you, after that, is what do you have to do with writing productivity? So like you, Randy Srinivasan is building complexity, and all the brilliant Indians who are frankly building the latest and the best in AI today in Silicon Valley or beyond. And is it possible to get Alpha come and work here for 5 years or 3 years or whatever it takes to really do some spectacular stuff for India?
Yeah, so I think first of all, India has great talent, right? We need to invest in the infrastructure, right? So the compute infrastructure is really important, right? An artist has to work with paint, right? So building up that right infrastructure is really important. Secondly, I think there's also something that India has that we are a country which has many different languages. If you think about any other country, the amount of diversity of languages, of culture, of values, and somehow the country is able to sort of capture that and move forward. That's so amazing, right? That they're like, the world, in some sense, has to see that as a role model when we think about coming together as a species. So I would really want sort of the bodies of the future and so on to have this sort of values that have been embedded. But I think we need to sort of start at the basics. Infrastructure and education. Everything else will follow. Right? People are remarkable. They sort of find the solution themselves. We just have to make the right conditions available.
Thank you, sir, and audience, for the including Q&A session. I now request Dr. Saraswat sir, member of NITI Aayog, to deliver the closing remarks.
Morning. A wonderful talk, very, very informative, and certainly throws light on artificial intelligence in its true perspective, with respect to its applications in various domains. I was really impressed by the biology, which you mentioned in a big way, and understanding of the protein to hemoglobin and so on, holding of those, using multiple protein structures and coming out. It was so informative for me because I'm not a biology student, so it was very, very. But in addition to that, what came out was its application into mathematics, physics, science, and other social sciences areas, which shows that artificial intelligence is all pervasive today. It is a society which is now going to work with intelligence as the tool, intelligence as the powering, the energy source. Unlike what we have had in the past, where we were using, as I said, the energy. The kind of answers and replies he gave for all the questions has covered practically all aspects of what artificial intelligence is all about.
I can only say that the effects of this are already being seen in some of the major areas, for example, in material science, diagnostics, and in fact, yesterday, when I was reading about what Microsoft has done, Madhurana, the Madhurana single chip, which is able to now do a quantum computing doing that. The whole thing came in because of the topology. The topology which is able to do 0 Kelvin, and it is to bring out the superconductor capability of the materials and utilize that. All this happened because of the kind of modeling that could be done using the artificial intelligence. Similarly, there are examples where new materials are coming today. The graphene, which is as strong as steel, but like a foam. That's the kind of a thing that's happening. So all this is going to happen. We have to accept it. But what I like about Dr. Kohli's point is the caution which you have thrown for all of us. That it is important for us to use it in a more responsible manner. And the responsibility will come with how we are able to actually regulate the whole process. Regulation is important, but regulation is not for throttling the growth of the technology. Regulation is only for making sure that it is used effectively. The other point which I would like to mention here is that in addition to what is being done today, the AlphaFold and other tools which are being done today also able to discriminate between what is fake and what is real. So that is a very good sign that shows that the scientific community, artificial intelligence community is realizing that if we are not able to explain, if we are not able to decipher from the fake to the real, then we will not be doing the justice to the humanity. I think that's a great thing that is happening. In addition to that, I would put it this way, India, the journey what you have indicated for us, yes, we need to have interdisciplinary approach to make sure that we have all the machine learning models. In fact, I have been part of this debate, which has been going on whether we have foundational models or only application on various platforms. And I'm personally of the opinion that from the point of view of security and point of view of having IPs, I think it is important that we should have a major go on the foundational model. This is my view, but certainly there could be opinions which are otherwise. We should learn our lessons from what we have had in the conventional computer science area, where we now built our own foundational models and built only applications. As a result, we are vulnerable as far as the security is concerned. So that is one part that should be done. Use of artificial intelligence in various applications, particularly strategic applications, I think it's a very important part. Because if you try to using this foreign data, using the data which has not been generated within the country and not in your own ecosystem, there is likelihood of getting results which are not applicable to you. So using the strategic areas, customization of all the applications is very important. If you don't customize using the data which is locally available, then you will be erring in that particular segment. So this is another one. Last point I would like to say that artificial intelligence is transformative. India has to really work in that direction. Certainly, there is a need for us for strong collaboration. A strong collaboration with people like Dr. Kohli and others who are there in the country and in the globe where they are able to do good work. But I think we have sufficient capability if we work in a collaborative mode to make some major dent as far as this particular science is concerned. Artificial intelligence for the areas which I have sort of identified is one of them, which Dr. Kohli also mentioned, was fusion energy. In fact, in the recent indication to the government of India, we have identified fusion as one of the core areas for research.
And if we really want to control the plasma using the magnetic fields, I think the control system has to be certainly based upon new models of artificial intelligence, which will provide that kind of a thing. What the world has taken 25, 30 years to build a tokamak, I think we can do it using this kind of an approach today in less than about 5 to 7 years. This is possible. This is what the Japanese have shown. They have been able to show that a small tokamak is working in their own country. Of course, they have not yet converted into electricity, but they have shown that positive energy is coming out. So this kind of a thing is feasible with artificial intelligence. I'm sure that the time is here, where we are all talking about diagnostics, also understanding the biology, that the Berkeley is here, where there's a lot of work being done in India on the genome sequencing, on the protein synthesis, synthetic biology. All of them will be the portion as far as the artificial intelligence is concerned. The transformative nature will certainly drive us to a platform from where we will be looking at the globe in a totally different way as compared to what we have done so far. So thank you very much, Dr. Puri, for enlightening us with all the great words. Thank you. God bless you.
Thank you, sir. As a token of gratitude, I now invite Dr. Saraswat sir to present memento to Dr. Kohli. Thank you, sir, for your inspiring words. Ladies and gentlemen, on behalf of NITI Aayog, I extend our sincere gratitude to our esteemed guest, Dr. Pushmit Kohli, for his thought-provoking session on the AI revolution and India's pivotal role in shaping the future. Your insights have enriched our discussion and broadened our perspectives. A heartfelt thank you to all our distinguished guests and their presence and contributions. I also extend my appreciation to Protocol Division, Administration at NITI Aayog for their seamless support in making this event a success. Lastly, I extend my gratitude to our dedicated team. Without whose help, we wouldn't have achieved this success. Thank you so much for your presence. Thank you. We have arranged high tea for our guest. Please enjoy the high tea.